I like dogs.
Oh, Lord.
I like cats.
So picking up where we left off. When we talked about those parabolas, okay, only if the board works. I wanna go back. When we talked about those parabola things, they did something like this, correct?
Yes.
What were these things called?
Solutions.
Zeros, x-intercepts.
Buddies.
I've heard them all now. What is this called?
Vertical.
Vertex.
Vertex.
It also could be called
Maximum or minimum.
okay. What's the domain of this?
What? The
You didn't tell us the points.
Negative infinity to infinity.
Yeah, right? And they're going to use all the x's because it's going to keep going forever? Okay. What's the range of this one?
Negative 2 to infinity.
Negative 2 and up, right? Negative 2 to infinity? We okay with that? Okay, so before we left for break, we were taking these little things we were putting in our handy-dandy calculator, and we were solving for these things. What are they called again?
Zeros, x-intercepts. Roots.
I've got one outstanding. What is it?
Zeros. X-intercepts.
There it is, solutions. So we were solving for those on our calculator. We get our calculator to tell us what they are. Now we're going to learn how to do that algebraically, but to get to that point, I'm going to introduce some ideas behind it. As we go through this, you're going to notice on your piece of paper that you don't have the same thing. I do want to start off with, before I even take you to our notes today, I would like for you to do a little refresher and do number 1 on your classwork.
I got this.
Which I do not seem to have.
A square, right?
Okay, so just in case we didn't remember, the big square is x by x, which gave us x squared. The rectangle was a length of x by 1, which gives us an area of x, and then the little square is 1 by 1, which gives an area of 1. We all okay with those ideas? Okay, so then let's see. If I were to draw 2x squared, I could draw them this way. And if you drew them the other way, that's fine too. I could have drawn them that way as well. So this is x squared and this is x squared, correct? So how long is this right here?
Something.
2x squared.
2x, right? It's x plus x, which is 2x. Does that make sense?
Yep.
Next thing I look at is this negative 3. I'm going to do it in red since it's negative, and my choice, I could do a 3 this way or I could do 3 this way. What way do you think? You want me to go that way? Okay. Does it matter? No. Oh, yes it does. If I do 3 this way, this is going to give me 1, 2, 3, 4, 5, 6. Negative 6 plus 1. Is negative 6 plus 1 negative 1?
No.
Is negative 6 plus 1 negative 1?
No.
So then that way won't work. So instead we're going to have to flip it. And we're going to have to do it this way. So it does matter. The minute you end up with a number right here that's anything other than 1, it's going to start mattering. So let's see. I'm going to have some negative x's and some positive x's. Do my negatives go here or here?
Right there.
I don't know where that is. Up here?
Corner.
Yeah.
Okay. So if I put my negative x's up here, pay attention, don't be writing. Then that means this would be my positives down here. How many positive x's do I have?
3.
How many negatives do I have?
2.
3 minus 2 is
1.
positive 1. Is that correct?
Yes.
Because that's a positive 1.
That's a negative.
So is this a correct drawing?
No.
So I'm going to have to undo all that. Instead, we need what? Whoops, don't want that.
The bottom red and then the top part.
Jeez. Crazy board. Okay, we need the bottom part to be red. And we need the top part to be the positives, right? Okay, so now I got 2x minus 3x, which gives me my negative x. Okay, so we said from here to here is 2x. Well, how long is from here to here? I'm going to remind you. This rectangle is an x by 1. X times 1 is an area of x. How long is this side right here?
1.
1. If it is red, how long is it?
Negative. What?
Negative x.
Negative 3.
If it is
Negative 3.
red,
Negative 3x.
Negative 3.
so no, it's not negative 3x. This is negative 1, negative 1, and negative 1. You're not the only one talking. So I got 2x what?
Negative 3.
2x,
Negative.
2x minus 3. So this whole side would be 2x minus 3. How long's that side?
X3.
How long is this side right here?
1x.
I agree. How long is this side right here?
1x.
Should
How
be
long?
X.
I keep-
X plus 1. X. No.
I'm going to remind you, the rectangle goes x by 1.
Plus 1.
How long is this right here?
It's just 1.
1.
Sorry.
It's what?
1.
So how long is this whole side?
X.
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 1x.
X plus 1.
X plus 1. So this whole side would be x plus 1, correct? That would be the entire length of that side. So our factors, the area of this entire rectangle would be this side times that side, correct?
Yes.
Those are called factors. Factors are things that, come on, enlighten me. Multiply. Factors are things that multiply. Well, if I take 2x minus 3 and I multiply it by x plus 1, what will I get? The answer's on the board.
What you started with?
What I started with,
Minus 3.
right? 2x squared minus x minus 3. Do you want me to prove it to you? I'll remind you how to FOIL. What do I get when I do 2x times x?
2x.
Okay. What do I get when I multiply 2x times 1?
2x.
What do I get when I multiply negative 3 times x?
Negative 3x. Oh,
And what do I get when I multiply negative 3 times 1?
negative 3.
And then we combine these to get 2x squared minus x minus 3. Isn't that what we started with?
Yeah.
So when I do this, my whole purpose is to unmultiply it. In other words, to find the factors. Factors are things that multiply. Yes? Okay, so the only real new thing is I want to actually solve this. If I want to solve it, I'm looking for solutions, correct? What are solutions? Zeros, x-intercepts. So in other words, I want to find where this graph does what?
Crosses the x-intercept.
Yes, crosses the x-axis. I'm looking for the two places, right? Where does it cross? Well, let's think about that. This would be what the graph looks like, correct? I want to know where it crosses the x-axis. What does y equal there?
0.
Nice. That means I'm going to let this be 0.
Uh-huh.
What times what gives you 0?
0.
If you multiply by 0. That means one of these things has to equal 0, right? So I will set them each equal to 0. 2x minus 3 equals 0. X plus 1 equals 0. Write it down on your paper. Now we're going to go all the way back to the very beginning of the year. The very first unit. And we're going to solve. Let's solve the easy one first. The one on the right. What do I need to do to get x by itself?
Subtract 1.
Subtract 1 from both sides. And what do I get? X equals negative 1. Remember how we started y equals 0? Notice how y equals 0? What does x equal? Okay.
Can you do this for every single problem?
This one, what would I do first to get x by itself?
Add
Add 3. If I add 3 to both sides, I get 2x equals 3. Is x by itself? No. So this is a two-stepper, right? What do I do now?
Divide 2.
Divide by 2. So once again, remember that y equals 0. Well, what does our x equal?
1.5.
Or 3/2. So if I were to actually graph this, I would have at -1, I would have a 0, correct? And at 3/2, I would have a 0. Correct? Does anybody know what the y-intercept is?
0.
How could that be?
Because
The y-intercept. Do we remember back in our quadratic book when we had to find the y-intercept, and there was a real quick trick when you looked at the standard form?
it's -3.
Very good. It's the constant, right? So I got a y-intercept at 0, -3. So I could plot that like right here. What would that rough sketch look? Could I connect that and make it look like a parabola? Do you think this would have a minimum or a maximum? So I could just draw a rough sketch, something like that. All from factoring and plotting the y-intercept. Okay? That's a little big picture for you. Our focus is just on this stuff. We're going to work on the factoring and finding those solutions. So now you try number 2. I don't need the graph. I want you to sketch it, find your factors, and solve.
Oh, you said, the first one was subtract 2.
Okay, so I end up with x equals -2, and then
Subtract 3 and then divide by 2.
subtract 3, divide by 2. So we ended up with -2 and -3/2. This is set notation. That's what I want you to notice, because you're going to ask me put this in multiple ways. For example, if it asks you to do it in coordinates, well, that's just the point. Like we just did in the previous ones. This would be a coordinate. Okay? If you're asked to write it as a set, this is a set. You do the little squiggly brackets, and then you just list your x values. When you write a set, you always write from smallest to largest. So which one of these is the smallest? -2. Okay? So if I were to graph this, that means I would have a point at -2 and -1.5. Those would be my 2 roots, correct? Okay? You want to try another one of those? Flip your page and try 3. So looking at this, no. When you look at this, I'm interested in what's the area of my green square? Can somebody tell me? My green square, my green rectangle. I lied.
200.
200. What's the area of my orange-looking one?
50.
50. Okay. What's the area of
40.
this blue one?
40.
Okay. And then what about that purple one over there?
That's 10.
10. Okay. So then what's the area of my biggest rectangle?
100, 200.
Of your biggest, like the
200.
hold on.
400. 300.
The biggest one is this one, right?
2000.
2000.
How long is this side right here?
That's
20.
Or 12. No.
12. How long is that side right there?
25.
What's 12 times 25? Because that would be this whole area, right? Which, of course, we could do the same thing. We could just add all those up, couldn't we? So the area of the whole is 300.
I did that in my head.
I saw you put down your calculator. So now, what you'll notice is, what do? We're still looking at the length of the sides, right? Just like you've been doing with your tiles. So the box method, if you like the tiles, the box method kind of works out, but it's a little faster than the tiles. I don't really like either one. I like the third way I'm going to show you, but we'll do these first. Let's try this again. What's the area of my purple-looking square?
10x.
Okay. What's the area of my gray one?
3x.
Okay. What's the area of my green one?
40.
Where is this?
It's on my board.
It's not on.
Nope.
It does matter.
Here?
No.
12.
What's the area of my teal?
12.
Okay. So then let's see. It tells me record the area of each rectangular region or box below. Okay. So I would just put what? 10x 40 3x, and 12, right? And then it says, what's the area of my largest rectangle? Well, how would I figure that out? I can just add them, right? Isn't that what I'm doing? So what do I get? 13x
And 52.
plus 52. You want to see if that works? How long is this side?
13.
So I got 13. How long's that side?
4x.
How long's that side?
4.
Thank you. X plus 4. What's 13 times x?
36.
What's 13 times 4?
52.
There you go. Did y'all just say that because you already knew it, or did somebody actually plug it in chat? Your turn. Try A. This is in your book, Chris. Try A.
What?
Wake up.
I am.
You can leave it who it is. You don't have to put it.
Good job.
No, it'll be as your notes. You're fine.
Yeah.
All right, Jason, tell me, what do I get for my first box right here?
3x.
What do I get for this box right here?
12.
Like, no, you have to
What do I get for that box?
5x.
And what do I get for this box right here?
40.
Okay, so then it tells me to record the area of each rectangular region below. So I got 3x, 5x, 12, and 20. And then what happens, how do I figure out what the area of the largest is?
Just add them.
And what do I get, Jason?
I don't know. I haven't done that yet.
Okay, I'll wait.
I don't know if this is right. I got 247.
Okay, well, let's think about it. Are these like terms?
Yes.
What do you get when you add these two up? Okay, so I got 8x. Are these like terms? What do you get when you add those two up?
32.
You okay with that? Okay, so let's try another. You don't have this one, so you have to look at mine. Notice this time they gave me all the inside, so I could already figure out the area. Can somebody tell me what the area of this box is?
Can't see
X
blue.
squared plus 7x plus 12.
Good. I guess they can. So then, notice they gave
No, I
me
can't
the
really see
length.
the
Hey,
numbers.
they gave me the length of one of the sides. How long is this side, Drew?
X plus 3. Sorry.
Why don't you step out or stop? Drew, how long's this side? Okay. So now, according to this side right here is how long, Drew? So if that's the case, how long must this side to be to give me an area of x squared right there? X, let's see. Does everybody agree? Everybody okay with that?
Yeah.
Okay, so then right here, the area of this one right here is 4x. Okay? So then how long does this side have to be able to give me that, Mia?
4x.
4. I agree. So how long is this whole side then?
4x.
Mia?
X plus 4.
X plus 4. I'm not multiplying, they're adding. How long is the side? What is the width of the largest rectangle? This is an interesting. When you think about length and width, how many of you think this is the width? How many of you think this is the width? Some of you didn't answer, and that's okay. The reality is probably half of you think this is the width, and half of you think this is the width. It's all in how you look at it yourself. I can tell you this, they gave us that. So when they ask me a question, what do you think they're asking me for? The thing I had to find. So according to them, this is the width. So, because that was what we actually had to find, right? So we got x plus 4. What is the area of the largest rectangle? You already told me this. X squared.
Plus 3x plus 4x plus 7x plus 4.
Okay, so I just added up the 4x and the 3x to get 7x. Are we okay with that? Okay, you try. B? What?
Can you come here for a second, please? I'm so confused on is this the,
They gave you this one. So whatever they're going to ask you for is always going to be the other one, the one you had to find. And that's the same thing. When you look at a rectangle, everybody sees it differently. I wouldn't try to tell you that this is the width and that's the width. To me, width, I think this one. So therefore, this ends up being linked to me. You know, if I looked at a link to the paper, that's the way I look at it, okay? But everybody looks at it differently. Okay, let's see, Jason, tell me, how long's this side right here?
X,
Okay? How long's this one?
2.
2. So what's my width that I had to find?
This side.
The one I had to find.
Oh, X plus 2.
Right. I mean, because to be quite honest, width to me goes this way. Right? That doesn't mean it does to you. You may look at this and say, oh yeah, that's the width. This is length to me. The way I look at it, I look at this way as length. Okay? So once again, keep in mind, they already gave you one, so whatever they ask you for is the one you had to find. What's the area of this big rectangle, Jason?
Are you-
The area of the big rectangle.
Oh, X squared plus 2x plus 5x plus 10.
Can I simplify that at all?
Yes. 2x and 5x,
Would be what?
10x. X squared plus.
I'm adding.
Oh, 7x.
Good. We okay with that? Okay, back to me. Looking at this one, they gave you the area, but they gave you no sides at all. So let's see if we can figure it out. If this is x squared, what must these be? So we think both of these are x? If this is x and this is 2x, what's that going to be?
2.
Okay. And if this is 3x and this is x, what's this going to be?
3.
So we've got a side that's x plus 2 long and x plus 3 long. Those would be our factors, the things that multiply to give us this area, correct? So let's see. It tells me what's the area of the largest rectangle. How would I figure that out? I would add all that stuff up. Of course, I could multiply, yes, but since they gave it to me, I'd add all that stuff up. Just like Jason told me to write it a second ago. This will simplify, right? Giving me 5x. And then keep in mind, this right here is the same thing as multiplying those two factors that we just found. So it says, what is the length and width of the largest rectangle? Okay, so which one do you think is the length? X plus 3 or x plus 2?
X plus 3.
Okay, so then we'll put x plus 3 here. And so therefore, then our width would be x plus 2. Would it be wrong if you put x plus 2 and x plus 3? No, it's all in how you look at that rectangle. Don't get yourself worried about that. Okay? So now you try C and D. What?
They are.
Very annoying.
For what?
Once you get your answers, compare with your neighbor and see if y'all did the same.
Miss Moon, you can do
Both of them, yes.
Miss Moon.
I'm like,
I'll take it. He doesn't want it.
And then,
I don't care what's in it.
I can't have these.
Say no, say no. I'll take it. Yes. Yes.
We'll go first. X squared.
Dude, I have
Questions, problems with these?
no.
We got x plus 7, x plus 3. Yep. X squared plus 10x plus 21.
Yes.
Over there we got 4x.
Yes.
Okay, good. Okay, so now I'm going to translate this straight up into the box method. And here it is. This is why I hate the box method. Because you have to draw a box. Anything extra I have to do, nope, means I'm not going to like it. I'm an efficient. The least amount to get to the right, I'll do that way. I have to draw a box, that's extra work for me. When you draw the box, you have to decide what goes in the box, okay? The squared term always goes in the first box. You're not writing this down, right? Because do you have, oh, you do have this. My bad. Yes, you are writing this down. The squared term always goes in the first box. Always, always, always. The constant always goes in the bottom box. Isn't that just like our tiles? Our squareds go up there, our constants go down there, and then our x's are over here. We don't know what the x's are. All we know is these two boxes have to equal that. That's all we know.
Yeah.
But then they gave us a cheat, and you're not going to get this normally. They gave us the length of one of the sides. Which side do we want it to be? This one or that one?
That one.
Okay. So 2x minus 3. If this is 2x, what's
Wait.
this? What?
Why is that 2x?
Because it says 2x. They gave us the length of one of the sides. If this is 2x, how long must this side be to get 8x squared?
4x.
Very good. Can anybody tell me how I can figure out what number goes there?
4x. You could do the 4x.
No, you need to do the bottom
and
to
then
see how much.
afterwards.
Okay, so explain to me about the bottom. What do you
You
mean?
have to do the bottom first, because then you'll figure out what that is, and then you just carry the rest.
Do you see this right here?
Yes.
Isn't it going to be this times this?
Yes.
Negative 3 times what is going to give me 6?
Negative
2.
There you go.
Never mind, negative 2.
That's another way to go about it. Yours would have worked too. So now that I have this is negative 2, what's the area of this box?
2x.
Be careful.
4x.
Negative 4x. Now that I know these two, what's the area of this?
Negative 12x.
Do these two boxes equal that?
Yes.
You always have to check that. You wouldn't believe how many times people complete the boxes and it doesn't work. Okay? So now what's the length of our rectangle?
2x minus 3.
Well,
4x
we actually were given that information, so what did we have to find?
4x minus
4x minus 2. You okay with that idea?
Yes.
Okay. I believe you have another.
We have another.
You try.
We have more questions.
Wait, we have
We have more questions down there? My bad. I'll scroll. Dimensions, binomial factors. Dimensions. Dimensions are the dimensions of the box, right? Length and width. Okay. Factors. Factors are things that multiply. Binomial. Does anybody remember what binomial is?
No.
Two terms. Two terms, right? Is this two terms?
Yes.
Is this two terms?
Yes.
And are those things that multiply?
Yes.
Binomial factors. So we got 4x minus 2. 2x minus 3. Okay, so now what I need for you to do in your graphing calculator, home one, no? Go to a graph, and I want you to type that in.
What? Okay.
Home one, no graph, type that in.
Just type it in.
Just type it in and push enter.
It says error.
Mine does.
Mine
You
too.
had error.
Did
Just
you
double,
solve?
no, you just put
Whoa.
F1, just type it in.
She's going way too fast.
Did we get that?
Sorry.
Mine like
Yeah.
hates me, I think.
Why?
I don't know.
You messed up.
Oh, oops.
Just hit tab, arrow up. Do we have that? Does your curve look like your partner's curve?
Yeah.
I don't have a curve.
Yes? Now I would like for you to hit tab. And I would like for you to enter this in.
Wait, where's tab?
Toward the top left, with the parentheses. What should happen?
Points.
Why should it come up as the same thing?
Because it's the same.
Because it's the same. These are the factors for that original one. This is a great way for you to check to make sure it's right.
It's red.
Sven, did you put it in? Put it in.
Oh, mine's not the same.
Uh-oh. Then you need to double check what you typed in.
Mine's the same. It's 3.
So if I gave you a multiple choice question and said find the factors for that, what could you do with your calculator?
Look at her.
Type in A. If it's the
100.
same, boom. Type in B, C, right? Just figure out which one's the same.
You took a nice.
We got that?
Hold on.
Okay.
It still isn't working for me.
Will this always work?
What'd you say?
Yes. The reason is because they equal each other. As long as they equal each other, they will overlap.
Okay, we're
What was
good.
the answer to this?
4x. Got it? Okay, so let's see. That's all we got for that. So let's go to our next one.
Okay, it worked.
Good. Okay, so here we go. We got to draw our box.
Wait, can we do this by ourselves?
I'm getting ready to let you.
Okay.
Which one is this one?
It's called class
It's the
work.
next one. Take a look at this one. Where do I put that?
First one.
First box. Where do I put this?
The one.
Bottom box.
Last box. And then I gotta find the rest. They gave you a cheat. They gave you the length of one of the sides. Is that gonna be this one or that one? Does it matter? No, you can put it for whichever one you want. If you want it to be this one, put it there. Then use all the information to basically finish your puzzle.
Yes, sir. Did I do this right? It's like there. It's like
That's the only thing is big, 4 times 1. So now just finish. This comes out, it'll be done.
Okay, done.
Okay, Jason, what'd you get for your width?
X minus 1.
X minus 1?
Plus 1.
Plus 1. X plus 1. Is that what y'all got?
Yes.
So then my binomial factors, what would those be, Jason?
X plus 1. And then 2x plus 1.
Good. Okay, now I want to go back to the same thing. Hit tab. Go up to where you typed in that first quadratic and change your numbers so that it's this graph. Or hit home 1 no and start fresh, whatever floats your boat. But if you hit tab and you arrow up, you could just change the x squared to be a 2 and you can change each one. It's up to you. Once you've got that in, I want you to put in your new binomial factors. what should happen if we did it right?
Match.
They should match. They would totally overlap, right? What do you think their tables would look like? They would look exactly the same as well, right? And they're going to produce all the same points? Hmm? Did your graph come out okay? Yes? Okay, so now let's go back to your classwork, and I want to bounce to problem number, we're going to jump to a little reality. Jump to problem number 9.
Problem 9.
Everything up till then keeps giving you helps. This is the first one where you don't get any helps. If you're using the box method, the only help you got is I drew the box for you. Wasn't that nice? It won't happen from now on. You'll get to draw your own box. So once again, help me figure out what can I put in here. Mia, what do I put here?
2x squared.
Okay. Wilbur, what do I put here?
30. Or negative 30.
Good. The negative matters. Now it's a puzzle. And it's a straight out puzzle because there's very little information. These two aren't too bad. What are the possibilities for these?
X.
How do I get 2x squared?
2x and x.
One's going to be 2x and the other one's going to be x. That's your only possibilities. It gets even harder when you get something like 4x squared. Because now it could be a 1 and a 4 or a 2 and a 2. Okay? So then after that, now you got to start figuring out, let's think about 30. What are my factors of 30?
15 and 2.
Okay, well, there's more than that. How about 1 and 30?
1 and 30.
How about 2 and,
15.
how about 3 and,
10.
what about 4 and
Nothing.
5 and
6.
5 and
6? Well, we got 6. 7?
No.
Are we done?
Yeah.
Okie doke. Those are all my possibilities of things that could go here. Remembering these two things have to match. See if you can put the puzzle together.
And isn't it negative?
Okay. What has to match?
It is, which means one of those is going to have to be negative.